Yo, what is that?
It's a water strider.
How is it like floating on the water?
Well, you see.
Yo, who are you?
What are you doing here?
Don't worry about it.
What is that?
Again, don't worry about it. I see you guys are watching a video of a balloon beetle.
I thought
Who's wearing the lab coat here?
isn't it called a water strider?
Name, shmame. Listen up. It's completely hollow and filled with helium. That's how it floats so gracefully on top of that water.
No, this is an example of surface tension. Surface tension is the ratio between the boundary forces and the length of the surface.
What? What's actually happening here?
Okay, let me show you.
Alright, so what's happening?
So, here are my notes.
Alright.
It describes surface tension. And there's no way in the third section here about surface tension.
Wrong! Let me tell you what's going on here. You don't even understand. The art of the balloon beetle. Balloon beetle, you got the air, and then you got the pull of Saturn and the Illuminati. And basically what they do...
No.
is,
No. No. Okay, so surface tension. Basically, it can be summed up as the elastic tendency of a fluid. So, with basic observations, you can see that under tension, liquid acts as a stretched membrane. So this is what happens with the water strider.
Oh, so that's how it's able to like stand on top of the water.
Yes. So, but also when this water glider is pushing down the water is also pushing back. However,
Due to Newton's third law.
yeah, what's most important are the cohesive forces between the water molecules themselves being greater than the adhesive forces between the water molecules and the air.
That's what causes the membrane.
Yeah. So, do you understand?
Yeah, I think I get it now.
well, hold up here. I thought that an object's ability to stand on water depended on its density and its weight.
That's a good point.
That's a different thing. That's buoyancy. Surface tension can actually show that an object can still balance itself on water, even if it can be like 10 times as dense as the water itself.
I don't know about that. That's how can it float on water if it's heavier than water?
That
Well, let's
doesn't
go
make
prove it.
sense.
Alright.
Okay. See, look.
Yo,
A paper clip, which is obviously more dense than the water.
Wow. Well, not anymore. Well, how do you explain that?
Why did you do that?
Okay.
Hey,
So once you apply more force and the length of the surface is constant, it could no longer hold up the paper clip.
oh, because then it's an imbalance of forces.
Yeah.
I'm still like having trouble visualizing what surface tension is. Like what is it?
Well, we see it in everyday life.
Like where?
Think of a droplet or a dropper. When you push water out of it, the water leaves in spheres.
Time out. What do you mean a sphere? It goes in a water droplet shape. Everybody knows the shape. Like, come on. That's what it looks like.
That's
And
that,
you know,
that
I'll
is the
tell you
shape
how
of
it
water.
how it gets that shape. As it falls to the Earth's gravity pulls on the bottom more than the top. That's why it's fatter at the bottom.
That makes sense. Why would it be a sphere?
There's a common misconception. This is false.
What do you mean it's
So,
false?
with surface tension, well, not specifically surface tension, but more on the cohesive forces of the water molecules interacting with themselves, they take on the shape of the least surface area, which is a sphere. That's why when it falls, it's not in the shape of that, but it's in the shape of a sphere.
So it maintains that sphere shape due to surface tension.
Yes.
That makes sense. Alright, so now I got a better idea of like what surface tension is, but are there any other real world applications for it?
Yeah, soap and detergent. Those are examples of surfactants, which are things that reduce the surface tension in the liquid, which allow it to clean the better. Let me show you. Anybody got any soap?
You know I keep it clean.
Okay. So,
Whoa, so it actually works. Like how did I do that again?
as we said before, it's a surfactant, which reduces the surface tension.
Oh, so with the reduced surface tension, it didn't provide enough force for the paperclip to stay afloat. Alright, so I'm learning so much about this surface tension stuff, but like when you compare two different liquids, how can you measure the surface tension of one? Like is it possible to measure surface tension?
Yeah, it's easy. I need a better place to show this.
I have the perfect place. Gather around. Join hands. 3, 2, 1.
Yo, where are we?
The lab.
The lab? What lab are you talking about?
Don't worry about it.
Alright, there's
Oh, there's a board. Okay. So you asked, how do you measure surface tension?
Yeah.
So surface tension, commonly denoted by gamma, is equal to the force over the length. Okay?
All right. Force of what though? What is the force?
The force is, these are the cohesive forces, also known as the intermolecular forces
Of the liquid.
itself.
All right. Okay.
And the length is the length over which the force acts.
So this is a very simple formula.
Yeah.
Where can we use it though?
Okay, so the soap bubble. So we already have the formula for surface tension.
Yes.
But also, we can really interestingly apply different physical principles. Pressure equals force over area. So force is the common thing in each of these. There's a pressure difference between the outside of the soap bubble and inside the soap bubble. So that's why this is here. And when the soap bubble is projected onto a plane, you have a circle. So we can use the different formulas for a circle to substitute into here. So that means that we have
All right. So surface tension is equal to the change of pressure times the radius divided by 2.
Yeah.
Wow. I really did learn a lot about surface tension.
Really? Tell me what you learned.
So I learned that surface tension is a phenomena where a liquid forms like a sort of a membrane on the surface, which provides a force for things that are denser than water to sit on top of the surface.
And that's why water droplets form in the sphere, is because of the stronger cohesive force of water molecules.
Yeah. Well, actually that makes sense because in my lab, I'm learning about the affliction of jaundice and how we can test for it. Basically what they do is that they test the urine of babies, and if there's bile in the urine, that means that there's jaundice disease. And bile also lowers the surface tension. So that's how they can test whether a baby has jaundice or not, by testing the surface tension of the water itself. Wow, so there's so many real world applications of surface tension.
I'm glad that we could clear up some misconceptions about surface tension also.
Wow, thank you.
You don't have to thank us, you don't have to mention. We're here to teach you about surface tension. Alright. Why are you whispering?
I don't know, it's not real stuff.
It's rolling.
Be like, several forces. Cohesion, adhesion. Shit.
Do you understand?
3 words. Are you recording this? I'm just still having trouble understanding like what surface tension is.
Why are you laughing?
Go with it, go with it, go with it. Roll out.
I still don't understand.
It's not possible.
Yeah. Soap detergent. They're examples of surfactants, which are things that reduce the surface tension.
Stop.
in liquid.
Okay.
Why are you laughing? We can hear.
Stop!
Are you playing this?
Yes.
Why?
So I'm learning so much about capillary action and surface tension, but when you're comparing the two,
They're trying to hold it in. You were staring at me like, I dare you.